In this video, we'll solve this system of three equations using Gaussian elimination. The first thing we'll do is write this system of equations in matrix form. What I've done here is pulled off of the coefficients, off of every variable, and then I've got these constant terms listed over here. So instead of 1 times x, I just have x. Instead of negative 2y, I have negative 2, and so on. What we are trying to get is we want it to look like, in the end, this diagonal of 1s. And it will look like this. Then we'll have our answers for x, y, and z. So we're going to pull some tricks or go through some a system of steps to get that. We already have a 1 right here, so that's good. We want a 0 right here. So what we're going to do is add some multiple of this first row onto the second row to eliminate this 2. And what that will look like is, I'll say a negative 2 times this, negative 2 times row 1 plus row 2, and then we'll replace row 2. That's what we'll see here. So that will be the next step that I'll show. So let's show this a little bit more clearly. The negative 2 times row 1, and row 1 is not being changed. I'm just adding some multiple of row 1 onto row 2. So what I'm adding onto row 2 is a negative 2, a negative 4, and a negative 2, and a negative 8. That's negative 2 times everything in row 1. Adding that to row 2 gives us, oh, this is a positive 4. This is negative 2 times negative 2 is positive 4. Positive 4 plus 1 is 5. Negative 2 plus 2 is 0. Negative 2 plus negative 3 is negative 5. Negative 8 plus negative 27 is negative 35. Now we want a 0 in this row. So we're going to add some multiple of row 1 onto row 2 to get a 0 right here. It'll just be negative 1 times row 1 plus row 3. And I'll show that. I'm showing a negative of row 1 plus row 2, or plus row 3, and that will replace row 3. I'll show the result here. And once again, I'm going to put some markers in here to show when I multiplied this row 1 by negative 1, I didn't change row 1. I was just saying some multiple of row 1 added to row 3. So I was adding a negative 1 to row 3 and a positive 2 to row 3 and a negative 1 to row 3 and a negative 4 to row 3. Negative 1 and 1 is 0. 2 plus negative 3 is negative 1. Negative 1 plus 3 is positive 2. And negative 4 plus 6 is positive 2. The next thing we want to do is get a 1 in this spot, just like we have here. So we're getting the process is to get the 1, get the zeros below it, or in that get the zeros in the same column on the rest of the column. So we've got that here. We've got the column with a 1 and then the rest of it zeros. We want a 1 here. So we're just going to multiply this row by some multiple to get this to be 1, or divide it by 5. So I'll say multiply by 1/5. 1/5 of row 2, and that will replace row 2. Okay, so now we are going to change the numbers in row 2. And we have this. What we want to do is multiply or add some multiple of this row, and it will be a multiple of 2. 2 times 1 plus negative 2 equals 0. And these other things will be affected as well. This 1 will not be affected because 2 times 0 is 0, and 0 plus 1 is still just 1. And that's good. We don't want to mess with the 1s once we have them. So I'm going to say 2 times row 2. I'll write that in red. 2 times row 2 plus row 1 will replace row 1. Okay, and remember, we did not change row 2. We just added some multiple of row 2. So 2 times 1 is 2. 2 times negative 1 is negative 2, and 2 times negative 7 is negative 14. And we're adding that onto row 1. 0 plus 1 is 0. 2 plus negative 2 is 0. Negative 2 plus 1 is negative 1. And negative 14 plus 4 is negative 10. Now we want to get a 0 down here in row 3 in this second column. This one, we don't have to do any multiples of row 1. We're just going to add, or of row 2. We're just going to add row 2 onto row 3, and that will eliminate this negative 1 right here. So I will write that in, that step that we're doing. That is row 2 plus row 3 will replace row 3. So 1 plus negative 1 is 0, negative 1 plus 2 is positive 1, and negative 7 plus 2 is negative 5. I should note here that we have a glimmer of a solution here. We have 1 times z. Remember how these were just coefficients of the letters? So 1 times z equals negative 5. So z equals negative 5. Our solution to z is negative 5. But let's keep going here. We have a 1 here. We don't have to do any of this business to get a 1 here. So we're just going to add. I'm going to do both of these in one step. I'm going to add row 3 onto row 1 and row 3 onto row 2, because both of these will get knocked out by doing that. So I will show that. I'll write down what I'm doing. I am adding row 3 plus row 1 to replace row 1. I'm also going to add row 3 plus row 2 to replace row 2. So to recap what we did here, we added row 3 onto row 1. Zeros, the zeros added to anything, don't change anything in row 1. 1 plus negative 1 is 0, and negative 5 plus negative 10 equals negative 15. We also added row 3 onto row 2 to replace row 2. Again, the zeros don't change anything. 1 plus negative 1 is 0, and negative 5 plus negative 7 is negative 12. Now we have this form, so this is very nice. I'm going to put a circle around this to show that this is the reduced form. And we can just pick these off. Remember, these are coefficients. So what we're saying is 1 times x plus 0y plus 0z equals negative 15. Or, writing that directly, that is x equals negative 15. Y equals negative 12. And z, we already saw that in the last section, z equals negative 5. And that is the way to solve using Gaussian elimination. I hope that helps.